Is it going? Okay. So we look here, and so I graph the cosine. So it's going to be in between 0 and pi over 2. Oh, we'll do sine first. So sine, I know, starts at 0 and then goes up to 1. So there's sine. And I know cosine starts at 1 and then pi over 2 gets down to 0. Oh, so I notice which one's on top. Yeah, they switch. So I might have to figure out where are they equal? Where do they intersect? And I always tell my trig class we love 45-degree angles because sine and cosine are the same thing. And tangent becomes 1 because you got same thing over same thing which equals 4. So this has got to be pi over 4. And we could do like we did in the warm-up. Hey, that piece looks an awful lot like that piece. Yeah, we could do that. But if you wanted to just take the two pieces and add them together, then from 0 to pi over 4, the one that's going to be on top is cosine. So that's going to be cosine x minus the one on the bottom, sine x. And then I want to add to that, if I don't change the one that's on the top, if I keep it cosine and say cosine minus sine for this piece, and they are exactly the same, I'm going to get 0 from my area. Because I'm doing what's really the bottom minus the top. And we want to do the top minus the bottom. Well, now sine is on top from pi over 4 to pi over 2. Now sine is on the bottom. So cosine, wait a minute. Sine is on the top. Yeah, sorry. Sine x minus cosine. So if we want to add the two pieces together, just make sure the reason you're adding them together is because the one on top flipped, and it's now the one on bottom. So that should give me, so this first piece, if I take the integral, that's going to be sine x. And the integral of sine x should be negative cosine, so I got negative plus cosine x. And I can take that from 0 to pi over 4. That's just a matter of plugging in a minute. And then I want to add to that the other piece, which, hey, the integral of sine, I think is negative cosine. And the integral of cosine is sine. Well, this one has a negative in front of it anyway. And I want to take that one from pi over 4 to pi over 2. So now it's just a matter of plugging all that stuff in. So I'm going to have sine of pi over 4 plus cosine pi over 4 minus sine of 0 plus cosine 0. Should be 0. Okay. And then I'm going to add this piece to it, plus, let's see, negative cosine pi over 2 minus sine pi over 2 minus minus the lower one, which is minus negative cosine pi over 4 minus sine pi over 4. Make sure to watch your negative signs, the first one minus the second one, and you know, if they already have negative signs in front of them, be careful. Which is why maybe it's worth doing this stuff. A lot of people will just plug it in and put the answers down here. I don't want to make a sign error. So now let's see what everything is. Sine of pi over 4. Ooh, I love me some 45-degree angles because sine and cosine are the same thing, which is root 2 over 2 plus root 2 over 2. This is why this might be a non-calculator one, because they would want you to know the basics of sine and cosine. And again, maybe not over 6 or over 3. Okay, so we got that. And minus what this is about to come out to be, sine of 0 is 0. Hey, we did that in graph. And cosine of 0 is 1. And then I'm going to add to that the other piece. So cosine of pi over 2, I think that's 0, right? So I've got minus 0 minus sine of pi over 2 is 1. Minus what I'm about to do here. Well, I could just pick up this stuff over here. Pi over 4, sine and cosine are the same thing. Minus root 2 over 2 minus root 2 over 2. Wow, a whole lot going on there. What I could do, well, okay, we'll just try to get rid of some of the multiple negative signs here. I got root 2 over 2. Maybe it's worth this extra stuff. Let's not combine anything yet. Let's just try to get rid of multiple negative signs. Root 2 over 2 plus root 2 over 2, 0 minus 1. And over here, I've got a plus. 0 doesn't matter. Oh, minus 1 there again. Plus minus 1. Minus a minus, which looks like it's going to be a plus, root 2 over 2. Minus a minus, plus root 2 over 2 again. Now I can probably add everything together. But it's a lot easier. I got rid of these multiple negative signs. So it looks like I've got 4 of these things, right? 4 of those things. 4 root 2's over 2 minus 1 minus 1 is minus 2. And then I could probably, that 2 can cancel with that 4. So I probably could have 2 root 2 minus 2. Yeah, if you want to pull the 2 out, that's fine. Now technically, if this is a free response question, I guess theoretically you could have stopped here because the rest is arithmetic after there. I sort of have this tendency to want to clean it up. I know it's hard for me not to go all the way, but yeah. The only thing left is arithmetic. They don't like to see arithmetic errors. So, if I have my double negatives, I kind of want to clean it up. That's your call. That's your call. Questions? And again, just like the warm-up, if you wanted to do this piece, if you were sure that this piece and this piece were the same, if you wanted to do this to this, which would have been this piece right here, and then multiply by 2, because this piece would be the same, you could do that.
Couldn't you just leave your answer at cosine pi over 4?
Technically, no,
Why not?
because that's not arithmetic.
Oh,
That's true.
okay.
So once all you're doing is basically adding, subtracting a bunch of pieces, then you could stop.
Okay.
Any other questions? Oh, let's look at one more then. Has everybody got this? Who wants this then? Okay. So, what was this, number 5? So number 6, the one I think which is right over here. So sometimes when I graph and I'm trying to figure out, well, which one's on top, yeah, sometimes they change. This one's on top here, but it's on bottom over here, and they want that whole interval. How do I find where that changes, set them equal to each other, right? Same thing that if they just say find the area in between and they don't give you, in between two curves and they don't give you an interval, you gotta set them equal to each other and figure out, well, where do they intersect here, where do they intersect? So, the only other complicated thing I can think of is something like number 6. In which they say, find the area enclosed by the line y equals x minus 1. Well, a linear equation I can pretty well graph. So there's that. And y squared equals 2x plus 6. You know, that's a parabola, but I'm used to seeing parabolas saying y equals like x squared. It's 2x minus 3. Is number 6 not on there?
It's on there, but there's not the.
It's not the second image.
It's just not the graph. Like.
Oh, good. Good. Excellent.
No.
Excellent. And so, and then this one is, well, it's a parabola with the y-axis, not a parabola with the x-axis, because it's not the x squared, it's the y squared. So I wrote this one. So there's this one. And here's the line, and they're not telling me the interval. I have to somehow figure out, it did say the area in between. Okay, so I went down. That's what I'm looking for. And I think I could probably find the points of intersection, right? Couldn't I do that? Just set them equal to each other? How would you want to set them equal to each other? I mean, we can use substitution. Y is the same as x minus 1. So I could say x minus 1, which is y. I've got y squared. Well, 2x plus 6. I could do that. And what does that give me? X squared minus 2x plus 1.
Yeah.
And then I got 2x equals 2x plus 6. So, yeah, I know how to solve a quadratic. Quadratic formula, if nothing else, if I can't factor. Well, let's see. I gotta set it equal to 0, so there's an x squared. If I subtract that, minus 4x. If I subtract the 6, that gives me what? Minus 5 equals 0. Two things that multiply give me x squared is x. Two things that multiply and give me 5. I'm kind of stuck. It's got to be 5 and 1, right? There aren't a lot of choices, 5 and And this is telling me, ooh, the bigger one better be negative, so minus. So that tells me x can be 5, x can be -1. So I'm guessing this is x equals the -1, and this is probably the x being 5. Perfect. Hey, I now know where they intersect. I should be able to set up the problem now. Let's find the area. Which one's on top?
2x plus 6. Wait.
Is it? 2x plus 6? I mean, I would really, if you're gonna say that, I would say because it was y squared, which was 2x plus 6.
So it's 9.
But is that the equation that's on the top?
Yeah.
Right here? Looks like it's on the top and the bottom right there. I can't really tell. What if I turned it sideways? This looks like it would be easier to work from the y-axis, because if I turned it sideways, let's see my hands. Okay, and if that's the y-axis now, and this is the x-axis. And then I take this, here's the line, and I'm looking for this area that's in between. Just by turning it sideways, I see, you know what? It's pretty easy to see the one that's on the top now. It's the line. But if I change it, I gotta put the equations in terms of x instead of in terms of y. So if I do that, this one becomes, this one's pretty easy because it's a line. X equals y plus 1. So this is y plus 1. And the other one will become, what, 2x equals y squared minus 6. X equals y squared minus 6 over 2. And if you don't like that, you could say, hey, that's, I don't know, that's fine, but if you want to say, I know I'm gonna have to take the integral of that, so that's 1/2 y squared minus 3. Hey, it might be easier to take the integral of that. Again, one thing in the denominator, put it under each term in the top, and then it makes it easier to take the integral. Oh, okay. So now it looks like this one's on the top and this one's on the bottom. Perfect. Okay, so the area, I mean, it's the same area, right? It's just easier to work it from the y. You could always do this. If, when you turn it sideways, there's one that's stable. Because a lot of people, when they first see this, let me back up, they'll say, oh, wait a minute, right there. This one's on the top and that's on the bottom, so I could find the area of that piece. And then find the area of this piece. The problem is, this didn't automatically become the top function over here. It's the same function that's on the top and the bottom. So that's gonna screw you up. So that's when I go, wait a minute. I'm gonna turn it sideways and see if it's easier to work it from the y direction. Okay, so I'm gonna do the integral of the top function, which is y plus 1, minus the bottom function, which we determined to be that one, minus 1/2 y squared minus 3. But you know what I need to do?
Change the interval.
Yeah, I need to change the interval. I'm going in the y direction now, not the x direction. Well, I got the x value.
Should they be equal to each other?
Well, no, because I've got the x and the two x terms here, right?
Yeah.
So I could probably get the y terms that go with them, and then just use that. And doesn't matter which one I plug. Why don't I plug it into this one? So when I plug this in up here, I get 5 minus 1 is 4. So when x was 5 over here, it was hitting y as 4. And I mean, I could plug it into this one, but then I gotta take the square root of it. You know, it's the same point. So why don't I use the easier one here? And what was the other x? 1?
I thought it was negative.
Negative 1. You are right. It's negative 1. Sorry. Yeah, because it was over here. So when I plug in negative 1 minus 1, I get negative 2. Okay, well, why don't I just use it? It's the same point. I'm just looking at it from the y side instead of the x side. So then I've got, it looks like I'm going from negative 2 to 4. That's all it is. Okay, so if I determine that looking at it from the y axis is better for me, then I gotta put the equations x equals. So I see y's in it and do dy. And then I also have to change my interval where they intersect. It's no longer along the x-axis, it's along the y-axis. And then I could take the integral of all these pieces, right? That's gonna be y squared over 2 plus y 1 over 1. And let's see, the 1/2 I can pull out, so that's gonna be y to the third, whoops, wait. Y to the third over 3 with the 1/2 out front, so probably y to the third over 6, 2 times 3, minus 3/1, and I can take that from negative 2 to 4. Let me see what you all get when you plug that in. We do actually get a nice round number. Oop. Look what I did. Ooh, that would have caused a problem. I have a minus, a minus. Minus that one, definitely a minus. So again, if we want to. Ooh, I didn't get 4.
I got 18.
I did get 18. Ooh, this is where you might want to be. Let's see, 4, that's what, 16 over 2 is 8, plus 16, 4 to the 3rd power. 16 times 3, was that 48?
Oh, that's what I forgot.
Minus 48 over 6, 6 minus 6, 48 over 6. Is that right? And then I got minus to do all this stuff in here first. Negative times a negative is positive, that's 4 over 2 is 2. Minus 8. 1, 2, 3, 4, negative signs. So that's gonna be 2 times 2 is 4 times 2 is 8 over 6. Well, 8 over 6 is 4 over 3. That'll be easy.
Wait, how did you get
Wait,
in 4
What?
square divided by 6? How did you get 6?
oh, this one right here, I
Yeah.
was looking for. 4 times 4 is 16.
Mm-hmm.
4 times 4, 4 times 4 is 16, times 4 is 64.
18
Right,
now.
right. So that's 64 over 6, that doesn't come.
You're not 18 now.
So we'll leave this, what was that, 8 over 6, thank you. Yeah. 16 times another 4, or 32. Okay, let's see what we can clean up here. That is gonna be 24 minus 64 over 6. Minus a negative 6 plus 6 minus 8 over 6. So that's gonna give me 30 minus something over 6. 72 over 6. And 72 over 6 is 12, right? Minus 12. Equal 18. Yeah, it's all those negative, 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 negatives. But if you graph, the point is, if you graph and you looks like, yeah, I can't really tell, like this is a great example. And it would just turn your paper sideways and go, oh, this would be easier. Well, then you gotta put everything in terms of X, and don't forget to change the intervals, because you're going across the Y-axis now. So you gotta find the Y points, which is pretty easy, because you probably found the X points over here. Plug them in, you get the Y's, take them over there with you. Questions? Oh, guess what we're doing tomorrow?
3D.
No, we still have this tomorrow. Sorry. Another day, so, but I think I've given you an example of pretty much everything you could expect. This is the big one, turning it sideways. An interval where the top becomes the bottom becomes the top. I think I've done it. Yeah. You have everything in your notes that you would need to do area. No, we won't do 3D till